Hi there, and welcome to the Echo Solar Home Tour. My name is Andrew Mills, and today we're going to be talking about a deep energy retrofit to a 59 unit townhouse complex in Edmonton. With me today is Peter Amarangan from Butterick Projects, the builder on this project. Welcome to the Echo Solar Home Tour, Peter.
Hi, Andrew. Thanks very much. I'm glad to be here.
Peter, this is a very interesting project where you're doing a significant upgrade to the building up envelope of a 15 building townhouse complex. This is the Sundance Housing Co-op in Edmonton, which was originally built in the 1970s. Peter, give me a bit of background on why you got involved in this project. What were you trying to accomplish with this upgrade?
Well, we're trying to accomplish quite a lot, Andrew. We've got a maintenance backlog. They wanted to do some exterior renewal, and they wanted to get the buildings ready for a low carbon, high energy cost future. So I think let's just start with the big picture with greenhouse gases.
Okay.
Um, to borrow an analogy from Bill Gates, greenhouse gases in the atmosphere are a lot like water, the water you left running in the bathtub. If you don't turn that tap off, you're eventually going to wreck your house. And it isn't enough to just crank it back a little bit. You've got to turn it right off. And at the rate we're going, Edmonton will have dumped its global share of greenhouse gases into the atmosphere, its fair share in the next 6 to 8 years. So this is an emergency.
Hmm.
And 40% of those emissions are coming from buildings. And 70 to 80% of the buildings that we'll be using in 2050, when we need to be carbon neutral by, that means no more GHGs, no more greenhouse gases, will still be filling that tub.
Hmm.
So there's simply no path to a decent future for our kids without massive deep energy retrofits to existing buildings. If we don't figure out how to do this, our kids are pretty much hooped. And this isn't political, this is just physics.
Okay. Well, Peter, where did you get the idea to add prefabricated insulated panels to existing homes? Where did you get your inspiration and how did this project come about?
Well, a few years ago, some NAIT students came to me looking for suggestions for an energy conservation related capstone project for their Bachelor of Technology. And I suggested that they do a feasibility study for a deep energy retrofit to the Sundance Housing Co-op.
Hmm.
And not really knowing at that time what the co-op already had planned. In their research, the students came across the Dutch energy sprong system. And this is a system where they build a whole new energy efficient shell around existing buildings by building panels in a factory that come to the site with new siding, new windows, and insulation, and they turn these old townhouses into net zero energy buildings. The roof panels even have racking for solar panels.
Hmm.
And they do this all in a matter of weeks with minimal disruption to the people living there. They call it zero on the meter.
Hmm. Interesting.
And so the Sundance Co-op is a 15 building, 59 unit townhouse complex. It's about 45 years old. And it's run by far-sighted, really well run by far-sighted co-op members who really think about the long term.
Hmm.
Back in the 70s, when they were building this project, the code was about to change from 2x4 to 2x6 walls, the minimum code. And they decided to go for 2x6 walls and give up closet doors so they could afford it. So recently, it was time to renew their mortgage and their lease with the city, and they knew this would be a good time to look after a maintenance backlog and any upgrades that they might need for the foreseeable future, like fixing any foundation and grading issues, adding egress from basement windows, and prepare for a zero emissions future and looming carbon taxes.
Hmm.
And their approach very smartly was, let's do this once and do it right. They knew it'd be a lot less expensive and far less disruptive in the long run to do that. So they hired Stuart Fix from Renew Engineering to do a building condition assessment to see where they were,
Mhm.
and energy modeling to see what would make sense in the way of energy upgrades. And Stuart hired me to do the building condition part, and Dave Butterwick to do the costing.
Hmm.
Uh, and the total cost was going to be about $5.4 million. And while they were thinking about the next steps, uh, I heard about an R&D program that Enercan wanted to do on this very thing, um, from a colleague in Ottawa who is working on putting Energy Sprong type panels on an ATCO trailer at the CanMed Energy Research Park.
Hmm. Interesting.
So he called us with this funding opportunity, and we applied for it and got it, and that made it a whole lot easier for the co-op. Um, and I can tell you, we're very grateful to Enercan for the opportunity, but I can also tell you that they're really getting their money's worth.
That's interesting. So now let's take a look at how you update these units. What are the upgrades you're doing to each home? Let's start with the building envelope. What's being upgraded on the building envelope?
Okay, well, let me tell you, just before I answer that question, I just want to show you what our starting point is. We've got some pretty complex buildings, especially compared to what they're doing in the Netherlands.
Hmm.
I managed to get a tour of some Energy Sprung projects in the spring of 2019, and I showed my tour guide some of these photos of the Sundance project. And I said, Simon, what would you do with this cantilever? We got these tight little jogs here, and we got some doors that are tight into corners, so there's no room for panels. We got porches. And Simon said, well, Peter, for us, that would be a no-go. And so we knew that Enercan was going to get their money's worth because we were going to have to solve a whole range of problems. So
Interesting.
anyway, so the general approach is we're wrapping these buildings in a nice warm parka that reduces the energy needs by about 70%. And we're it's a nice warm breathable panelized parka. So we're adding insulation to the foundation, the wall panels, which are filled with cellulose, and also dealing with the roofs and air tightness. So we start with panels that are made by our panel partners in Killam, Alberta, and they're lightly framed 2x4 panels, just enough structure to carry the new siding, insulation, and withstand wind loads and the stresses of handling and transportation. The windows are installed, and so is most of the siding.
That's really interesting. I understand that one of the first steps you do, however, is to capture the dimensions of the original building. Tell me how you accurately capture the building dimensions.
So we are using some very cool technology. We start by scanning the existing buildings with a laser scanner, and the scanner rotates in 360 degrees horizontally and back and forth vertically, and it fires a laser shot at every point in space in a big dome, and the recorder in the scanner captures the locations of those and makes the 3D locations of them. And then we had our surveyor, Bernie Jess, do this, and he went to capture the entire co-op. He set this thing up in 55 different places, and then took all of these files back to the office where he smooshed them or registered them together into one gigantic file that also, the process also removes any duplicate points. So he then takes this monster 170 gigabyte point cloud,
Hmm.
and he clips out each building and sends us a 5 to 10 gigabyte file that we start to process.
Hmm.
And then we take that file into a program called Undet, which works inside of SketchUp, and that program sort of looks at the array of points and said that looks like a plane. There are so many points all together in one in a sheet there, and so it extracts wall geometry from that. We direct it how to do that, so it's getting the ones we want. And then once we have a essentially a 3D model of the building, we install windows on that we can slide around, windows and doors that we can slide around until they're a perfect fit, or as close as we can get it on these fuzzy points, to what we can see in the cloud. We can see the cloud and the SketchUp geometry at the same time. And it's a bit nerve-wracking because the consequences of getting a window in the wrong place are pretty terrifying. It would just
Hmm.
grind us to a halt on site. But it's way better than a tape measure, because with a tape measure, you can get a very high degree of accuracy, but you're taking hundreds of measurements, and the chances that you're not going to screw it up and mix up just a few of them, which would have really terrible consequences, is very low. And you're going to be out by feet then potentially, where here the worst we're going to be out is a little bit of tolerance.
Well, I was cutting drywall this morning, and my tape measure didn't give me the right number, and I had to ruin a piece. So I
I
totally
get
understand.
it, and we were checking this against site measurements, and we were tearing our hair out, and it turned out that most of them were within a few millimeters, and there was this one that was off by 27 millimeters. And we thought, what the heck? How can that be? And it turned out we'd written 13 instead of 31, or whatever the
Dear,
transposition was. And
it
that's
was in your transposition of your numbers then.
exactly, yeah, yeah. It
Wow.
was, I can't remember what exactly it was, but whenever we were out by anyway. So we take the SketchUp geometry with the windows and doors,
Hmm.
and we divide that up into wall panels, uh,
Okay.
and um, and then uh, for each wall panel, we draw 4 drawings, one with every stud. We've got an automated thing that does that. We draw every cellulose fill hole, all of the lifting holes,
Hmm.
where the water resistive barrier goes, what siding goes on, which window goes in that panel, and we ship that off. So on a typical building, there would be 20 to 30 panels, so 20 to 30 drawings. And then we've got another file of about 15 standard detail drawings. And we have to do another set of drawings for our guys in the field on the for attaching these things to the building, and another bunch of, so there are hundreds of drawings.
Hmm.
It's a huge amount of work, and we're having to kind of invent this system from scratch, including a quality control method. It's daunting. Um,
That's really interesting. So once you've got all the dimensions figured out, you fabricate the panels off site, which is very interesting. And then what happens next?
so while they're building the panels off site, we're getting the building ready, and we start because we by taking off the old porches, and a little bit of hand digging around the exterior. And then we use a hydrovac truck to suck a very narrow trench along the edge of the foundations that we can drop styrofoam insulation into. And the to just about grade, just to the, and we also bolt a double 2x10 ledger on the exterior of the buildings. And if you notice that in that section that the wall is actually overhanging the
Oh,
old
yeah.
foundation, well, that happened when they changed from 2x4 to 2x6 walls. So
Oh.
without changing, I guess the foundation drawings were already done. And so that made it a little more complicated, but we kind of took it in stride. But we we then once the insulation is in, we build this insulated, pressure treated wood box that is also a structural member that's designed to carry the load of the panels and the porches that we have to put back, any roofs and that kind of thing. And we also run our new electrical service, which we'll look at in a minute, inside that box. So we're making things do multiple things at once. Yeah. So and then once the building is ready for the panels comes the big day. We've loosened all the windows. We can't leave the buildings open overnight, obviously. We've loosened all the windows so that on the big, scary, exciting day, we can get the windows out really quickly and drop the panels into place without freezing people uh, too much. And the reason it's scary is again this notion of panel fit. If these things don't fit, we've got a window in the wrong place or something like that. We got 6 people in our crew, and we got a crane there, and these panels are pretty much finished. The idea of starting to move windows is just a nightmare.
Mm.
Um, but I'm very happy to say, and proud as heck to say, that on our first go round with the offsite built panels, every single one of them fit beautifully. We didn't have to modify a single opening, and it was there were high fives and big whoops and hollers all the way around.
Nice.
So we're pretty pumped that we've got a workable system here.
Neat.
We have a 10 millimeter tolerance. We've shrunk the panels by about 10 millimeters, and we can cover that with trim on the outside. So we can slide them back and forth a little, but we hardly even had to use it. So,
Hmm.
and you'll see just in the panels that there's a flap of membrane, particularly up in this top one here, that's part of our system for making the whole building airtight and waterproof.
Hmm.
Which is the next step. We once we have all these panels installed, we knit the membrane together, sealing all the flaps, and finish installing the and this membrane is special stuff. It's highly airtight. It's easy to seal together, and it's very vapor open and waterproof. So any moisture that's inside the building that happens to get into the old walls from the interior, nothing is perfect. Everything's got a tiny bit of leakage,
Mm-hmm.
can diffuse right through. And then on top of that, we've got a rain screen. We've got an airspace behind that very durable, hardy siding that allows any rain that gets through the siding to drain harmlessly to the bottom. It never gets trapped. So part of what we're doing here is making them airtight, and we're very pleased with the results there as well. We started off with buildings that we tested to be 3.5 to 4 air changes an hour,
Mm-hmm.
and we're down to in the 0.6 range. So just about passive house tight.
That's
So
pretty good.
so yeah, we're pretty happy with that. And on top of that, and one of the huge values in the process is that because the exterior is detailed so well, it will be incredibly durable. These buildings shouldn't need any maintenance to speak of for a very long time.
Hmm. Hmm.
And then we do the roof, and
Ah.
we
Oh,
wrap
that's interesting. There's a flying roof.
a flying roof. It just flaps those scissor truss arms and gets up there by itself. Yeah. And we're working on that. We haven't quite got it. We still have to use a crane, but uh, we wrap the old roof. We cut off the overhang, Herald or chainsaw retrofit style, and wrap the old roof with poly. Leave the old shingles on. Tie that into our new magic air barrier to get full air tightness, and then put this new roof over top. And then we put another R50 on top of the old R28 that was there for essentially a net zero level building.
Wow, that's pretty good. So, what other systems? This is the envelope, obviously. So, what other systems are being upgraded as part of these renovations?
Well, because we've made it airtight, we have to add HRVs, which pay for themselves very quickly because they save so much energy by giving you that fresh air preheated by the old outgoing stale air. But it's kind of, we have to install them sort of laparoscopically, doing minimal amounts of cutting and opening of walls and that sort of thing. We're getting pretty good at it. And then we use the existing furnace ducting. And the other thing we are doing, the co-op has decided to get rid of gas altogether. We're electrifying the heating and cooling and hot water by adding air source heat pump heating systems and air source heat pump water heaters, just as we would in a modern net zero energy house. And in the process, the co-op is getting rid of roughly $38,000 a year worth of fixed meter charges by essentially putting in their own utility system that's pure electric.
So, you're removing all the gas furnaces and all the gas appliances then and going all electric. Do you have anything that you're going to have to do special to accommodate these additional electric loads? It sounds like there'd be need a lot more power now.
Absolutely. The original 60 amp service, which is under, nobody would build that today.
That's 60 amps per unit.
Per unit, yeah,
Okay.
is way less than you would normally, you would normally go with 100 amps. But it was never designed for the extra load that heating and hot water is going to apply, especially at minus 30 when the heat pumps are essentially working at an efficiency of about 100% rather than the 200 that they are normally working at. So this was expensive and a whole nother adventure, basically. But we installed a whole new electrical service, kind of laparoscopically with directional drilling, and are setting up the co-op with its own kind of mini utility. Their inverters are being installed so that they can do a solar system that connect right into the new sort of electrical distribution sheds that we're building.
So a whole new electrical system and then solar on top of that.
Yeah, we're putting solar on about a 350 kilowatt solar array modeled to produce about 75% of the total annual remaining energy load for everything, for heating, cooling, hot water, lighting, and appliances. And then they'll buy the rest that's not generated on their roofs from some off-site renewable source. So they'll be essentially net zero.
Wow, that's a great upgrade. Re-insulate all the units, swap out to modern electric heat and appliances, and then add solar to generate electricity on site. That's a lot of work. Can you give me a breakdown of project costs? What were the key costs in doing these retrofits?
Well, we're so the retrofit work is about $100,000 a unit. the panel costs are with the siding, insulation, and purchase of the windows are under 30% of that. About another 30 or less is going into the mechanical upgrade, and the rest would be on-site labor. And then the electrical upgrade was about $10,000 a unit, and another 8,300 for the solar system. So this is all being paid for by the lower long-term total cost of ownership. The energy savings, including carbon taxes, lower maintenance and replacement, enhanced value. The NRCan funding helped a lot, and plus they got a pretty favorable rate on their new lease renewal from the city of Edmonton. The city was a huge partner in this project. They were very excited about seeing this first of its kind energy sprung project in North America happen in Edmonton, and see it as a model for other Edmonton buildings.
That's really cool. Now, another thing that we were talking about earlier that's really interesting to me is that during the panel installation, the tenants continue to live in the unit. How do you minimize the construction impact on the tenants and the neighbors?
Well, we have a principle. Job number one is to make life better for the people living there. And it's obvious we're going to do that in the future. They're going to get warmer, healthier, more comfortable buildings with lower energy costs, beautiful new exteriors, and some little enhancements that we've worked in. We're putting bay windows on most of the living rooms. We've got skylights in the porches that are brightening up their kitchens. But at the same time, the co-op is very, we're also providing some short-term pain. There's no question about that, and some disruption, and not everybody is completely bought into this, and we're in their living spaces. It's not, so the co-op has a great committee of hardworking volunteers that we work with to manage expectations and solve the inevitable problems that arise. And we're so grateful to that committee. They're so sort of wise in their people skills and judgments. This is a huge part of learning how to do this kind of project, and it's going pretty well. We're learning a ton every day, and this is one of the many lessons that we're committed to sharing and documenting.
So that's great. Now, how far along is the project? How many units have you completed, and how many are there to go?
We've done 9 units now. We're on our 4th building, and we've got basically, so we're 9 done, 2 underway, and 49 to go. So it's a big job. It's not going as fast as we had hoped. We are getting faster every time. And that part is exciting. We have an amazing crew. They're incredible. They're always looking for better ways to do things. They're completely bought into the goals of the project, and they're smart as a whip. Like, they're just, I just love those guys. And we just couldn't do this without them.
Fantastic. So what's next after Sundance? Where do you go from here?
Well, we're about to start a 3-house version of this project, where we take these concepts and apply it to single-family houses.
Oh.
That's got some funding assistance from SSRIA, provincial carbon tax money, and we're trying out a new way of digital capture using drone-based photogrammetry. A brilliant young computer programmer has developed a system to do that we're really excited about. Amazing results, and way cheaper and less work for us, less uncertainty. So that's exciting, and so that's a big thing. But we're having to train people. Like, we're using the Sundance project as a training ground to build another crew to grow this thing. And of course, we've got our hands full documenting the lessons learned.
Right, right.
Yeah, so, and we're in the process, we've started a website that we're going to use to tell these stories and try and help people, because there's a desperate shortage of information for how to do this stuff. It's really complex work.
Well, thank you, Peter, for joining me today and sharing pictures of this interesting home. I think that's a fantastic project, and I am looking forward to seeing more of it completed over the coming years. I also want to thank our Echo Solar Home Tour sponsors. Our sponsors have many interesting services to help you build energy efficient homes, and we encourage you to visit them. Please visit our website to find the links to all our sponsors. To find more about our tour homes, tour dates, and our sponsors, please go to our website at www.ecosolar.ca. We'll see you on the tour. Thanks very much for watching, and thank you, Peter, for joining me today.